Hello guys. Welcome to the another insightful video in our cloud computing series. Today we will explore the chapter 4 part 1, the concept of service and applications and service oriented architecture and cloud transactions. So understanding the SOA is a fundamental to grasping how modern applications communicate and function seamlessly. We will dive into the key concept like the protocol stack, the event driven SOA, the service catalog. Then we will explore the cloud transactions, their attributes, and how they enable the efficient application functionality. Finally, we will touch on advanced concepts like the cloud bursting and APIs. By the end of this video, you will have a strong foundation in how services and applications thrive in the cloud. So let's get started. So now the service oriented architecture. So SOA, it is a framework that enables the applications to communicate through the services, often using the message based transaction. These services are loosely coupled. We already seen the software engineering also, meaning they operate independently while working together as a part of a large systems. Means in a large system, the modules are independently works. The core idea is to create a reusable service component, which is streamline the development and maintenance also. The SOA relies on a protocol stack, including the HTTP, SOAP, XML, to handle the service request and responses. By adopting the SOA, businesses can integrate the heterogeneous system, ensuring the flexibility, the scalability in applications design. SOA also supports the modular development, making it easier to update individual component without affecting the whole systems because every modules are independently works here, loosely coupled. So now the protocol stack for SOA and event driven SOA. So the protocol stack in SOA include the various layers like the transport, HTTP, message, SOAP, description, WSDL, and discovery, UDDI. This layered approach ensures the smooth communication between the services. Event driven SOA takes this a step further by enabling the systems to respond to specific events in the real time. For example, an e-commerce platform can automatically trigger inventory updates or the customer notifications upon a successful transaction. Event-driven SOA is crucial for dynamic and responsive applications as it promotes efficiency and enhances the user experience by reducing the delays in the system operation. So now the Enterprise Service Bus ESB and service catalogs. The Enterprise Service Bus is a central component of SOA that manages the communication between the services. It acts as a mediator, ensuring data is transformed and routed correctly across the applications. Service catalogs, on the other hand, are repositories that document available services within an architecture. They provide the metadata, usage guidelines, performance metrics, enabling the developers to utilize services effectively. Together, the ESB and service catalogs enhance the system interoperability and streamline the resource management, ensuring the smooth operations in complex distributed system. So now the concept of cloud transactions. Cloud transactions refers to the interaction that occurred when applications access or manipulate the data in the cloud. These transactions are characterized by their scalability, fault tolerance, and high availability. Unlike traditional transactions, cloud transactions often span multiple distributed systems, requiring the robust protocols to maintain the consistency and reliability. Functionality mapping in cloud transaction ensures that application processes are efficiently distributed across the resources, optimizing the performance. This concept is integral to the modern cloud based system, where maintaining transactional integrity across the dynamic and elastic infrastructure is essential. So now the functionality mapping and application attribute. Functionality mapping involves aligning the application processes with cloud infrastructure capabilities. For instance, a high demand application might leverage auto scaling to allocate more computing power during the peak times. Application attributes such as scalability, reliability, and fault tolerance guide how functionality is mapped to the cloud. This attribute ensures that cloud services meet the specific performance requirement. By understanding this mapping, organization can design the applications that take full advantage of the cloud resources while ensuring a seamless user experience. So now the cloud services, attributes and system abstraction. Cloud services attribute defines the essential characteristic of services such as on-demand availability, elasticity, pay-per-use pricing. System abstraction, meanwhile, simplifies the complex operations by hiding the underlying technical details from the user. For example, serverless computing abstracts the infrastructure management, allowing the developers to focus solely on the code. This attribute and abstraction make the cloud accessible and efficient, enabling the businesses to innovate without being bogged down by technical complexities. So now the bursting. Cloud bursting is a strategy where applications automatically switch to the public cloud resources during the demand spikes, ensuring the uninterrupted services. This hybrid approach allows the businesses to optimize the cost by maintaining a smaller private infrastructure while utilizing the public cloud resources when the need. For instance, an online retailer might employ the cloud bursting during a holiday sale. This strategy ensures the scalability, the reliability, while minimizing the need for permanent infrastructure investment. Okay, so now the application and the cloud APIs. Application in the cloud leverage the APIs to interact with cloud services. Cloud APIs simplify the operations like the data retrieval, storage management, workload distribution, and popular APIs include those offers by the AWS, Google Cloud, Microsoft Azure. These APIs enables the developers to integrate the cloud functionalities seamlessly into their applications, fostering the innovation and enhancing the user experience. APIs also facilitate the interoperability, allowing the applications to interact across the diverse cloud platforms. So now let's wrap up our deep dive into the service-oriented architecture and the cloud transaction. We have uncovered how SOA underpins the efficient communication in the modern applications and how cloud transactions map the functionality for scalability and abstraction. Concepts like the service catalog, cloud attribute, and APIs are vital for leveraging the full potential of the cloud environment. So, thank you for joining us today. And don't forget to like, share, and subscribe for more engaging lessons on the cloud computing. See you in the next video as we continue exploring the vast possibilities of the cloud technology.